Hello and welcome to Learning Rust programming series. My name is Ashish and today we are going to learn about static dispatch and dynamic dispatch in Rust. So in Rust, dispatch refers to a mechanism used to determine which implementation of trait or method to invoke. So it can be compared with polymorphism in object-oriented programming language, where we have static binding and dynamic binding. In case of static binding, compile time only binding happens and compiler knows which method to call. But whereas in dynamic binding, at runtime, compiler program comes to know which method to call. So something similar we have in Rust through static dispatch and dynamic dispatch. So there are two main types, as I said, static and dynamic. So first is static dispatch. A static dispatch, also known as monomorphic dispatch, occurs at a compile time. The compiler determines based on the types involved when which specific function or method implementation will be called. Let's take an example. So suppose I have trait animal which has function make sound. So this is associated method for So I'm going to create now struct dog and structure cat. So I have structure dog, structure cat. Let's implement make sound and inside println. And for cat also we need to provide implementation. And cat makes sound meow. Okay. So this is my implementation. Now let's go to main and create first of all dog instance. All right. Now if I make dog dot make, sorry, it should be small. Yeah. So let's make dog dot make sound and cat dot make sound. Yeah. So if I run this, yeah. So here what has happened, compiler knows at compile time that make sound function. So here we are calling make sound function. This make sound function, we have different implementation at compile time itself. So based on variable dog and cat, based on variable. So I'm pressing. So here also, if I do control and hover, then I can directly go to method make sound of cat. This is about this was about static dispatch. Now let's talk about dynamic dispatch. Dynamic dispatch is also known as I have already mentioned, it's the polymorphic dispatch, which occurs at runtime. It allows for flexibility in calling different implementation of a trait through trait objects. So if you have some configuration which you want to pick up at runtime, then this is very useful and very popular in object-oriented programming, that is polymorphic dispatch. So in this example, what I'm going to do is, so we have this implementation as it is. Now we are going to add one method here. So let's say I have perform sound method, which takes parameter as animal. And here I'm going to, so we are borrowing this instance, that's why ampersand. So if you want to know more about borrowing and ownership, you can check our one of the previous video. So here we don't want to own the instance, that's why we are borrowing. We are just creating reference, and this divn keyword is used where we want to create dynamic dispatch. That's why we are using the divn keyword, and type, that is animal. So we are taking animal type, which we don't know at compile time. We are taking it as a parameter, and we are going to make. Now here what is going to happen is, when I do animal dot make sound, it is going to look at where it is going to look at. It is going to look at trait. So it is very same concept. We have interface. So here we have created in. Let's assume that here we have created, instead of creating concrete class reference, we have created this dynamic reference, which is of type animal. All right. So now if we call, so instead of, so this is perfect. Now what we can do is perform sound, and we'll pass dog and we'll pass cat. So now this binding is going to happen. Oh wait, and we need to, so as I mentioned, we need to pass ampersand, that is, yeah. So this is we are sending reference or rather pointer to this function. If I run this, then output is same, but here we have used dispatch. So perform sound function takes a reference to a trait object ampersand animal. At runtime, the appropriate make sound method is determined based on actual type of the object passed to the function. This is dynamic dispatch. Now let's understand when to use. So static dispatch, statically it is generally more efficient because the compiler can optimize based on known types suitable for scenarios where the set of types is known at the compile time and the configurations is not going to change much. So there you can use static dispatch. Whereas dynamic dispatch you can use if you want flexibility by allowing different types to be used interchangeably through trait objects. You don't need to stop your program just through the configuration. If you want to interchangeably change the type, implementation type, then you can use dynamic dispatch. It's useful when dealing with a collection of objects of different types implementing a common trait. Incurs a runtime cost. So dynamic dispatch is a little bit costly because at runtime, it requires, if you are from if you know, if you're coming from C++ background, then there is a concept of vtable, that is virtual method table, and same concept is used here also in Rust. So the cost of maintaining that vtable and mapping that happens at runtime. So choosing between static and dynamic dispatch depends on specific requirements of your code, and often it's a trade-off between performance and flexibility. Rust ownership system and type system allows you to express both static and dynamic dispatch in safe and ergonomic manner. So thanks for watching my video. That's it from this video. Please like, share, subscribe if you are liking my content. Thank you.